So this is the 10th problem of Pure Mathematics Paper 1 Variant 2 of June 2011. The A part says a circle. So a circle is divided into 6 sectors. So 1, and the sectors are not equal in length. The angle increases in an arithmetic progression, where the largest angle is 4 times the angle of the smallest sector. So if we say that this is the smallest sector, we increase the sector a bit more, increase it. We have 1, 2, 3, 4, 5 sectors, and we divide this in 2. We can say that this is the largest. This is 4 theta. It's not entirely accurate, and this is the smallest. Add in increases. So we know by our arithmetic progression formula, that is a plus n minus 1 into d, where a is the first term. This is the nth term, by the way, nth term. D is the common difference, and n is the numbered term. That is, the first term is a, second term is 2 minus 1 and 1 d plus a, etc. So what do we do now? Let me make this full screen first. So we know that our sixth term, because if we arrange the angles in order of a sequence, we know that theta, comma something, comma something, comma something, comma another thing, and then the sixth angle being 4 theta, because the last and the largest angle is 4 times the smallest angle. So we take this as a sequence. We know that a plus n minus 1d, in this case n is 6. We have n plus 5d is equal to 4 theta, where a is equal to theta plus 5d is equal to 4 theta. From this equation, we can find the common difference. So 5d is equal to 3 theta, d is equal to 3 theta by 5. Now, I hope you've taken this down. I'm going to clear this page. Now we have 6. Now we can find all these terms. We know that the first term is theta. The second term is theta plus 3 by 5, because the common difference is 3 by 5. So 3 by 5 plus 1 is 8 by 5. So 8 by 5 theta, comma, second one is 8 by 5 plus 3 by 5, which is 11 by 5 theta, comma, 14 by 5 theta, 17 by 5 theta, and finally 4 theta. So this is our sequence. We have filled out these gaps over here. So now we know that in a circle, the sum of all the angles in all the sectors is equal to 360. If we take that same sector, same circle that we did. So we can say that theta plus 8 by 5 theta plus 11 by 5 theta plus 14 by 5 theta plus 17 by 5 theta plus 4 theta is equal to 360, which is equal to, if we add all this up, 1 plus 8 by 5 plus 11 by 5 plus 14 by 5 plus 17 by 5 plus 4 is equal to 15. We know that 15 theta is equal to 360, and theta is equal to 360 divided by 15, 24. So we know that theta is equal to 24. Now I'm going to clear this page. I hope you've taken it down. Now that we have found out that theta is equal to 24, we can use our equation for finding the arc length, that is 2 pi r into theta by 360, and finding the smallest arc length. The smallest arc length in this case is 24 degrees. We know that 2 pi, and we have given the radius as 5 into 24 by 360. So what is this now? 24 by 360 into 10 into pi is equal to 2 by 3 pi. Now that's the arc length. Now we're trying to find the perimeter. That's what the problem says. Now an arc, the perimeter of an arc, we can draw this like an ice cream cone, is basically the arc length. Let me just draw this again. The arc length in orange plus the sides in blue. Now the sides in blue stays 5. It's the radius. So we can say it's 5 plus 5 plus 2 by 3 pi, which is equal to 10 plus 2 by 3 pi, which is equal to 12.1 centimeters, since the radius was 5 centimeters. And this is our answer. Now going to part 2, let's clear the page. Hope you've taken it down. Going to part 2, the first, second, and third terms of a geometric progression. So we can say a geo progression. So the first term is 2k plus 3. The second term, wait, let me just explain this to you. The nth term is always ar to the power of n minus 1, where r is the common ratio. N is the numbered term, same as before, and a is the first term, numbered term, and a is the first term. So we know that we can say the second term is 2 minus 1, a into r to the power of 1, so ar is equal to k plus 6, and the third term, which is ar squared, because it's 3 minus 1, 2, is k, and k is a constant. So given that all the terms of the geometric progression are positive, calculate the value of the constant k. So we can find the value of the constant k. Now how do we do this? Well, we can substitute for one thing. We can say that we know that a is equal to 2k plus 3, so we know that 2k plus 3 r is equal to k plus 6. Or, there's an easier way to do this. Let me just erase this. Always find ways to substitute like it's simultaneous equations. If we take a the subject of the formula, we have k plus 6 divided by r. That is in the second equation. We call this the second equation, and this is the first. Then we have a is equal to k plus 6 divided by r, and this is equal to the a over here, which is 2k plus 3. So if we do this, we have k plus 6 is equal to 2kr plus 3r. Now making this full screen, we can continue over here. I hope you've taken this down. We know that k minus 2kr is equal to 3r minus 6. Now taking k common, we know that 1 minus 2r is equal to 3r minus 6. And k is equal to 3r minus 6 divided by 1 minus 2r. Now what is our r equal to? Our r is equal to k plus 6 divided by a. This is actually quite a difficult way to do it, so we're going to try another method. We have a equal to 2k plus 3, and we have ar equal to k plus 6, and ar squared equal to k. Now we have k equal to ar squared, so we know that k is equal to 2k plus 3 r squared. And we know that r is equal to k plus 6 divided by 2k plus 3. So if we're going to solve this, we can say k is equal to 2k plus 3, substitute r for here, and we have k plus 6 the whole squared divided by 2k plus 3 the whole squared. And this whole thing in brackets. I hope you can see where I'm going here. Now making this full screen, we can delete this page. We know that k is equal to k plus 6 the whole squared divided by 2k plus 3, because 2k plus 3 and 2k plus 3 cancel out. Now we know that 2k squared cross multiplying 2k squared plus 3k is equal to k squared, so expanding this, k squared plus 12k plus 36. So we know that k squared plus 3 minus 12k, 3 minus 12k is minus 9k, minus 36 is equal to 0. Now solving this as a quadratic, we know that k can equal to, we can use the quadratic formula here, or you can use factorization. K, I'm just doing it in my calc, k can equal to 12 or minus 3. Now k cannot equal to minus 3 because all terms have to be positive. So we rule out this answer. So k has to equal to 12. Now let's check if our answer is right. Just trying to find my mouse here. K is equal to 12. So we're right. Now I'm going to clear the page. I hope you've taken it down. Just expand this, clear this page too. Now going on to the next problem. Find the sum to infinity of the progression. So k being equal to 12, we know that k is equal to 12. I'll just use another color. K being equal to 12, we can say that the first term of the progression is 2 into 12 plus 3, 27. A is equal to 27. And we know that the sum to infinity of a geometric progression is a by 1 minus r. Now what is our r? Let's find out our r. So our second term, that is a into r, according to our nth term of a geometric sequence, is basically k plus 6. Our ar is equal to 12 plus 6, which is 18. So r is equal to 18 divided by our first term, 27. So what is 18 divided by 27? 18 divided by 27 is 2 by 3. So expanding this, we know that since our sum to infinity is a by 1 minus r, we know that our a is 27 divided by 1 minus 2 by 3 is equal to 1 minus 2 by 3, 27 divided by answer is equal to 81. So 81 should be our answer. Let's check the answer. 81 is our answer. And that's that. So if you have any questions on this problem, please email me. And see you in the next lecture.